So we're still doing trig. We're still doing trigonometry. Now we're specialized. We're doing equations. So we'll start with the same equation that I've seen there. Solve and √3 sine 2x is equal to cos 2x. I think that's how it's expressed. Let me check on the chart. Yes, like that. Okay. So, well, we don't divide to lose. But if you are keeping it somewhere, you can divide. So we'll divide by cos 2x. We'll divide by cos 2x. Okay, so this side it has cancelled. We have 1, 1. So we have √3. What is sine? So this is √3 sine 2x over cos 2x is now equal to 1. Divide by √3, divide by √3. Now we have sine 2x over cos 2x is equal to 1 over √3.
So he said,
Okay, then you say, what is sine over cos? This is tan. Tan 2x is equal to 1 over 3. Like that.
so then when he quote, you knew that after
Like that.
so when he
Which becomes what?
Yeah, no.
So, well, let theta be equal to 2x. So that now we have tan theta is equal to 1 over 3. Remember, this is coming from not from the big pi. This is coming from 30, 45, or 60.
I waited all that long.
Is it 30? So check if you have forgotten, you put this is 30. This is 60. Like that. This is √3, 2, 1.
After that,
Tan whatever angle is equal to 1 over √3. Tan is opposite over adjacent. So it is 30. So we know theta, in this case, theta is 30. This is in the first quadrant. Where else is tan positive? Because this is positive. Tan is positive in the third quadrant. So you say 180 plus 30, which is 210. But look, your theta is 2x. Because of these 2, we'll go around the quadrant. We'll come back with theta and add 360. We'll go to 210 and add 360. Meaning we are getting coterminous. So this will be 390. The other one will be 360 plus 210. 570.
From there again, 424.
When you come to x, you divide by 2, you divide by 2 to get x.
Yes,
let me do it somewhere. Let me do this.
Yes, the voice
Okay.
you
So when you come to x, you say, okay, since theta is 2x, if I divide by 2, I divide by 2, then x is equal to theta over 2. Meaning 1 We go round, we have 4 thetas. So 1. X is equal to
That's when he
30
did the
over 2,
after that,
which is 15.
and then you come by but no.
The second one, X is equal to
Then I called
210
off,
over
and
2,
then my mind,
which is
I called, but no.
105.
That was 9, no,
3.
so
X
but
is
they
equal
were
to
breakfast.
390 over 2,
And then it was
which is
I was waiting because you were saying that you
195.
that's when I called you. No, but you know, if you talk to this
4.
about
X is equal to 570 over 2.
That's why I didn't put that.
That is
find out so that you communicate
285.
So
So these are the values of X.
Yes.
Degrees.
Yes. So now just waiting.
So that's how you find your angles. So
The next communication
if
was
the inner one is a double angle, then you add to these two angles, you add 360 once. If it was 3, would have added twice. So would have said again 390 now plus 360. Again 570 now plus 360. So this would tell you how many angles you need. Your solutions will always be this by 2, 6.
And then he just said, no,
Like that. Hello.
but the message was nafika hapa.
Can you repeat on adding 360?
So because
Like what do you have?
So for you to add 360, you are saying, okay, since for me to get X, I need to divide theta. This gives us a room to go beyond 360 because we know that when we divide by 2, we'll come back to 360. So we are solving this for values of X between 0 and 360. So because you know, oh, I can have 500 bigger than 360, but dividing it by 2, it will be 250 less than 360. So it's when your angle has been doubled or tripled that you think of going beyond 360.
Yes, it's likely that I will plan because there are a lot of activities happening. Yes,
that's what you do there. Another one. B. If we have tan X is equal to cot X.
So
very simple. Okay. This is tan and this is cot. These two, to start with, they are equal when X is 45. Because tan 45 is 1. Cot 45 is also 1. So if you know that, then you say X is equal to 45. 1. But these two again, they are equal in all the 4 quadrants. They are positive at the same time. They are negative at the same time. So you say, oh, okay, since they are equal at 45, they should be equal at the angle related to 45 in the second quadrant. So you say X is equal to 180 minus 45, which is 135.
About 947 is when I started off.
Again, they are equal in the third quadrant. 180 plus 45. This is 25. Again, they are equal in the fourth quadrant. 360 minus 45, which is 350. So we are done. We've done this because these two are equal in all the quadrants. And so if they are equal to 45 and they carry the same sign in all the quadrants, then we'll go around all the 4 quadrants.
So I have a question.
Yes.
How did we get 45? X is equal to 45.
So because we are saying if this is the triangle 45, 45, and this is 1, 1, root 2. And now we know that tan x is sin x over cos x. Okay. And we also know that tan so I want to get tan 45. What is tan 45? Tan 45 here is 1. What is cot 45? Cot 45 is 1 over tan 45.
That one was just
Which is 1 over 1. Which is 1. So because here they are equal, they are giving us 1, 1. So when we are told tan is equal to cot, then we know it is at this angle 45 where the two are.
Unless they make coming all the way.
That's the easiest way. Or if you can track it from there, then you change them. You say, okay, tan is something like. Or you say, okay, tan x is equal to what is cot? Cot is 1 over tan. Cross multiply. That will be tan squared x is equal to 1. Meaning tan x is equal to the square root of 1, which is plus or minus 1. So we have tan x is 1, or tan x is negative 1. Again, we are back to 1 and negative 1. So tan x is 1 positive in the first and third quadrant. In the first quadrant, x is 45. That's where tan is 1. In the third quadrant, it's 180 plus 45, which is 225. Tan is negative in the second and fourth quadrant. In the second quadrant, it's 180 minus 45, which is 150, which is 135. 135. In the fourth quadrant, 360 minus 45, which is 315. So even this way, you can get there.
All right, thank you. I now get it.
Good.
And by the way, that is a good property without it contains so life for good. Life for good before.
So what else? The identity I'm looking for, if I can find it. Okay. That's fine. So this is just generally how you handle the equations. So what is key is if you get a positive, for sine, and you know one angle. You know it's 30 or it's 45 or it's 60. Then look for another quadrant where sine is going to be positive. Like that. You always do that. Okay. What about the graphs? The graphs, we'll talk about only two graphs. One, f of x is, we'll just do an example, 1 plus 2 sine x minus 90. You should be able to tell what the period is here. The period is 360 over b. B is the coefficient of x. So in this case, it is 1. So 360 over 1, which is 360. Then the scale is period over 4, which is 360 over 4, giving us 90. The vertical shift. The vertical shift, 1. Horizontal shift, you get this and equal to 0. So x minus 90 equal to 0. So we get x equal to 90. The amplitude, they can ask you to state this. Is the absolute value of the coefficient of sine, which is just 2. I remember in last year's test, they just asked for these properties without asking to sketch. Then because you don't read questions most, you just look, oh, it's this sketch. People say the sketching that being asked. Imagine the time.
Nothing.
Sir.
Hello.
Oh yes, I have a question on the horizontal shift. The way you find the horizontal shift, is it the same with doing negative divided by b? Is it accurate as well, or maybe we should just doing what they're doing?
Doing negative?
Negative c divided by b, following the James equation for such an equation for trig.
The horizontal shift, you just get the inside and equate to 0.
I should get the what?
What is, you should get the angle, the inside of sine. This whole thing. And equate it to 0. Oh, it's like that.
Oh, okay, thank you.
Okay. Okay. Then now we want to sketch this. Well, we already have the scale. So say, okay, since we have the scale, we use this. You start from the horizontal shift, 90, and add your scale. So we want to sketch it from 0. Let's say equal to x. Let's say equal to 360. So you add 90 plus 90, you get 180. Plus 90, 270. Plus 90, 360. We must get to 0. So you say minus 90. So we have 0. We've covered on the left. And then substitute. So what is f of 0? You get 1 plus 2 sine negative 90. Now remember what sine does. If you're negative, if there's a negative, sine will pull the negative out.
Yeah, it
remains positive. Sine 90 is 1. So we'll have 1 minus 2, which is negative 1. So yes, this is negative 1. Then you do what is f of 90. So following the angles, that would be 1 plus 2 sine 90 minus 90.
It was blue, but
That is 1 plus 2 sine 0.
no,
Sine 0 is 0. So I'll just get 1. So we have 1 here. Then substitute 180. That is 1 plus 2 sine 180 minus 90. That is 1 plus 2 sine 90. Sine 90 is 1. So we have 1 plus 2, which is 3. If I get 3 different values, then I'm done. The next one at 270, it will come back to 1. At 360, it will come back to negative 1. And then you draw a curve. You don't have to calculate all the angles. You just need to get 3 different values. And then you have your sketch. The beauty about this way is that you don't get to shift anything. When you solve the angles, they will shift for you. By the time you place your graph, it will be a final thing. And are they difficult to calculate? No, because they are all from the big 5. Remember, 0, 90, 180, 270, 360. The scale only gives you these angles when you're calculating. Meaning you always have 0, negative 1, 0, negative 1, 1, 0, negative 1, 1, just like that. And then you get the numbers that you have there easily. Yeah, it's true. You get the full marks. What you want is the final graph. So there's a question of interest here. 1 minus absolute value, of course, 2x. So this was, hello.
When you've been given that scale from 0 to 360, in order for you to come back to 0, do you always have to subtract the scale from the horizontal?
Yeah, you subtract the scale until you get to 0. But if the scale goes beyond when you subtract, then you cut it at 0.
Okay.
Yes. Okay. So we have a question. We have a question. F of x is equal to 1 minus cos 2x. Like that. So 1 minus cos 2x. So there's absolute there. So first you ignore the absolute. Okay. Sketch the function 1 minus cos 2x. So check what's the period? The period is 360 over 2, the coefficient of x. We get 180. Then immediately I get the period, I'll be getting the scale. The scale is period over 4. So I'm saying 180 over 4, which is 45. Then I get that inside, I'm now looking for the horizontal shift. So 2x is equal to 0, meaning x is 0. Then I get the vertical shift. That would be 1. Or do they want the amplitude? The absolute value of negative 1, which is 1. So now I'm sketching. So, okay. The period is 180 and the scale is 45 and the horizontal shift is 0. So I'll start from the horizontal shift from 0 and then add 45. Hello.
Is the vertical shift 1 or -1?
It's 1. No, the vertical
Oh,
shift is negative. No, it's 1. Yeah, it's +1.
oh, okay.
Yes. So you get this one as it is.
All right, sir.
Okay. So you start from 0, add 45 plus 45 plus 45 plus 45 plus 45. Is it 225 plus 45? So where am I going? I want to go all the way up to, I want to go all the way up to, I want to go all the way up to 360. So this is 270 plus 45, 315 plus 45, 360. Enter. Then, so I'll get the first angle. So the first angle, 0. I substitute. Now in substituting, I'm not bringing in y. I'm taking in the actual f. So what is f of 0? F of 0 is 1 minus the absolute value of cos 2 by 0. This is like 1 minus absolute value of cos 0. And what is cos 0? Cos 0 is 1. So 1 minus 1, 0. So we get this point there. Then do f of 45. That is 1 minus absolute value of cos 2 by 45. That is 1 minus absolute value of cos 90. Cos 90 is 0. So we have 1. So we place that 1 here. And then now f of 90. So we have 1 minus absolute value of cos 2 by 90. That is 1 minus absolute value of cos 180. Now what is cos 180? Cos 180 is -1. So I'm putting it in the absolute. So we end up getting 1 minus 1, which is 0. So it comes here. Are you seeing that? So this tells us the pattern. Also the absolute, but in case you can't see the pattern, you draw again. To the next angle, 135. So you do f of 135. That is 1 minus cos 2 by 135. That is 1 minus cos 2 times 135. That's 270. Cos 270 is 0. So we get 1. Get back to 1. So you're thinking it will go up, you try again. F of 180. That is 1 minus cos 2 by 180, that is 360. Which is 1 minus cos 60 is 1. So it gets 0. It comes down. So it will go back, come down, go back, come down. So it means you have a tail in this way. Like that. So that's because of the absolute. It has blocked it from having the central line, because you know the normal graph of sine was supposed to be something like Of course, I mean where this is the edge, the middle line, and the upper line. So now it has blocked the upper line. It's turning to this. Go back. Turn. Go back. Turn. So that's the impact of the absolute. Okay. But you see, if you are trying to shift, you get stuck because that's why I don't like the one for transforming. Because if I was trying to transform here, how do I transform the absolute? It's a bit stuck. So, but the angles will do it for me. Hello. Okay, so this was for sine, and this is for cos. I think if you know this for trig, it should be set for the test.
So I have a question.
Yes.
Okay, so you said the vertical shift was 1.
Yes.
And then the horizontal shift was 0.
Yes.
And so our graph started from 0. But I'm not seeing any shift for the vertical shift on the graph. Are we shifting it, or maybe it remain like this? Is it still okay?
No, it remains like this. So the shift is being done by the angles themselves, the news angles. So the impact of the absolute value there has made us not to see the vertical shift. Hello.
You are saying something about the one where we do not replace, and you said, how do you shift the modulus? So like the 1 minus the modulus of cos 2x, doesn't that mean that we're not supposed to exceed 1, which means that those points that are on top, they're supposed to come down. Can they come down?
No, no, no. The angles have refused. They're saying there's no going down here.
Okay.
Yeah. So that's why I'm avoiding the one for transforming, because imagine you face this question and you're used to transforming, and then you have the absolute. So you're thinking, absolute, does it mean I shouldn't have a positive? I shouldn't have a negative, I should have positive. Oh, what does it do? It's a bit tricky for you to see what it does. But the angles, when you use the angles, you forget about the vertical shift. The angles will do that thing for you. They will place the points that you just have to connect using those scales. Okay. We leave it here for tonight. That is enough for trig. Use those identities to run through the identities that you've met in the quiz. Yes?
So, okay, I just want to clarify. So you meant to say that if we use this method to graph, we should not worry about the vertical shift and everything.
Yeah, you don't need to
Just
worry
be like
because
this every time we're graphing. If we
exactly. This method takes care of all those. Chelsea. Have we done any examples on proving the identities? No. We just did the basic identities. Well, you don't prepare yourself to meet the identities that you have seen outside. The identities is what I meet is what I prove. They're just like equations. What you meet is what you solve. They're like graphs. How it comes is how I graph it. So we just do a bit of some basics. So even for the identities, you just need to know the basic and say, okay, so if I meet this structure, I will change it to this, depending on what they want the other side. It will guide me on what I should do. For as long as I have the basic, those that we have stated there are the basic ones that you need to know. The sine A plus B, cos A plus B, tan A plus B. And that sine squared plus cos squared is equal to 1. And that 1 plus cos squared is equal to cos x squared. Tan squared plus 1 is equal to sec squared. Just those, they're the main identities that you want. How the identity comes guides you on how you do it.